Let's talk about 1.3, radical equations. So far we've done equations before, but we've only worked with linear equations. Today we define what is a radical equation, and then we're going to talk about how do we solve these radical equations. So, you've probably worked with radicals before actually. Remember, a radical, for example, we have the square root of x. Let's go ahead and write square root of x is equal to, 4. This is a radical equation. It has a radical, in this case my square root, of some expression that involves x. In other words, x is inside of my square root. So this is a radical equation. One point I want to make is that just because an equation has a radical, that does not necessarily mean it's a radical equation. Again, a radical equation is when I have my variable inside of my radical. For example, if I wrote x is equal to, the square root of 8. This is not a radical equation. A radical equation has x inside of it, some type of way. So let's talk about how do we solve a radical equation. So I like to break it down into a couple of steps. Step 1, I need to isolate my most complicated radical. In other words, I want my square root or a cube root or whatever type of root we're working with to be by itself. Here I said the most complicated radical because sometimes you may encounter equations that have more than one radical. After I isolate my radical, I can go ahead and move to step 2. I can eliminate the radical by taking both sides of my equation to an appropriate power. In other words, I had to figure out what power will get rid of my radical. Step 3 is if I still have a radical equation, I continue to rinse and repeat. Isolate the radical, raise it to the power, continue forth. On step 4, I have to check my solutions. One interesting thing about radical equations is that sometimes they may give you something that we call an extraneous solution. In other words, an answer where you've done everything correctly, but it actually gives you something that is not correct. That is a fake answer. So we'll work through these, and then we're going to go ahead and follow our 4 steps for solving a radical equation. Starting off with example 1, solve for x. Here I have the square root of 2x minus 1 is equal to 1. If I follow my steps for solving a radical equation, first off, my radical must be isolated. Well, if I look at this equation, I definitely have an isolated radical. I have the square root of whatever is inside, all by itself on the left. And then everything else that's not a square root is on the right. So, I'm done with step 1. Step 2 is that I go ahead and I want to get rid of my radical. So I have to think, what's the opposite of a radical? Or in this case, the opposite of a square root. Well, the opposite of a square root is squaring the quantity. So if I look at this equation, I'm going to go ahead and square my left quantity, and then square my right quantity. If I do this, again, I said a square root and a square will cancel each other out, leaving me with whatever is inside of my radical. In other words, I get 2x minus 1 on the left, and on the right, 1 squared, that's 1 times 1, or very nicely, I have 1. Now, this looks a lot like just a standard linear equation. We can go ahead and try to solve for x. I would go ahead and start by adding 1 to the left and to the right, leaving me with 2x is equal to 2. After that, I want x by itself, so I'm going to go ahead and divide by 2, leaving me with, on the left, 2 divided by 2, I get 1x. On the right, 2 divided by 2, I also get 1. So I claim x equal to 1 is a solution to my equation. We should go ahead and check our answer. If I plug x equal to 1 back into my original equation, let's see if I get a true equation. So I have the square root of 2 times, instead of x, I can write 1 minus 1. That's my left side. I want to see, is this truly equal to 1? So on the left, if I clean it up, 2 times 1, I get 2. 2 minus 1, I get the square root of 1. Well, the square root of 1, that's just 1. So I'm asking, is 1 equal to 1? Yeah, that's definitely true. So that tells me, yes, x equal to 1 is a solution for my equation. And hence, we are done with example 1. Now let's go ahead and try something similar for example 2. Another radical equation. I have the fifth root of 1 minus 2x. Then minus 1 is equal to 0. Going through my steps, I need an isolated radical. In other words, I want this fifth root to be by itself. If I want to isolate my radical, let's go ahead and add 1 to the left and to the right. If I do that, I'm left with the fifth root of 1 minus 2x is equal to positive 1. Now I have an isolated radical. Now I can move on and try to get rid of my radical. Well, here I have a fifth root. It's a little bit different than before when I had a square root, but we had to do a comparison. To get rid of a square root, I squared both sides. So to get rid of a fifth root, I take both sides to the fifth power. So I would take both sides to the fifth power. That leaves me with 1 minus 2x is equal to 1 to the fifth power. That's 1 times 1 times 1 times 1 times 1, which just gives us, well, 1. Now I'm back to a very similar step. I see that I just have a linear equation. I'm going to go ahead and move my 1 on the left to the right. I'll do that by subtracting 1, leaving me with negative 2x is equal to, well, 0. And let me go ahead and rewrite this equation up here. Now all I had to do is divide by negative 2, giving me x is equal to 0. And once again, I claim this to be a correct answer or a correct solution to my radical equation. And just like example 1, I can go ahead and check my answer. As it turns out, if I plug 0 back into my original equation, then yes, I will get that this equation is true. Hence, x equal to 0 is a solution to this radical equation. So we're done with example 2 now. The last example I want to cover is example 3. Again, it looks very similar. I want my radical to be isolated. So right now, my radical is not by itself. So let's go ahead and do some rearranging so that my radical is by itself. Let's go ahead and subtract 5, for example. If I subtract 5 from the left and from the right, then I get negative fourth root of 4x plus 1 is equal to 7 minus 5. I've got 2. Now, one thing we need to be careful about is, right now my radical is still not isolated. There's a negative in front of my radical. So, to get rid of that negative, Let's go ahead and divide everything by -1. So if I divide the left and the right by -1, I'm left with, well, the fourth root of 4x plus 1 is equal to -2. Now, I'm going to go ahead and look at this equation, and I'm going to claim that there's a problem. I have an even root, the fourth root. I had to ask, is it possible to take an even root of a number and get a negative value? For example, this is just a side note. If I took the square root of anything, is it possible to get a negative value? The answer to that question is no. We should not be able to take the square root of some value and get a negative answer. We've always seen the square root of whatever number is a positive or at least non-negative answer. This actually applies for any even root. So if I look at this, I have the fourth root of 4x plus 1 is equal to -2. My fourth root can never equal a negative value. In other words, this can never happen. Well, what happens whenever I can't solve for x anymore? Well, all that means is that I have no solution. And sometimes you might see this notation. It looks like a 0 with a line crossed through it. This also means no solution, or more formally, the empty set. So there's no way that we can actually solve this equation, simply because the square root of a number should always be positive, or in this case, the fourth root should always be positive. Hence, we are done with example 3. And actually, that's our last example for this section.